All right, the problem we're going to be going over today is best time to buy and sell stock 2. Uh, this is a really common problem. Best time to buy and sell stock. I think there's 1, 2, 3, and 4, if I'm not mistaken. Uh, but the if you've ever done best time to buy and sell stock, this one's pretty similar. So you are given an integer array prices, where prices I is the price of a given stock on the ith day. On each day, you may decide to buy and or sell the stock. You can only hold at most one share of the stock at any time. However, you can buy it, then immediately sell it on the same day. Find and return the maximum profit that you can achieve. So it's kind of like buy and sell stock 1, but you are allowed to continuously make profits. So if you have prices 7, 1, 5, 3, 6, and 4, then you would buy on day 2 when the price is 1, and sell on days 3 when the price is 5. Then you're able to buy again on day 4 and take this profit here from going from day 4 to day 5. So then you have the profit of 4 plus the profit of 3 equals 7. Okay, so let's say we're given this sample array, right? And we know that our answer is going to be, we know it's going to be 7 because this is the one we just looked at. So we know this because we know that this jump here is equal to 4, and this jump here, these are our only increases in price, and this jump here is equal to 3. We know that we're not going to take, like, let's say this jump from 1 to 6 because we can get this profit here, and then we have another profit from 3 to 6. So we want to figure out a way to maximize our profit by taking the most efficient choice at every step. And I think the problem with this question is it's really easy to get caught up in, like, what's the optimal time to buy, what's the optimal time to sell, but we actually don't really need to keep track of that. All we need to know is, have we gained a profit since our current value? Because no matter what, that profit will always be realized, whether we sell it at a certain date now or sell it at the later date. So what do I mean by that? So if I am holding it at $1, so my current value is equal to 1. That's the value that I'm holding at. So, right, so like I buy on day 1, and then I get to, I buy on day 2, and then I get to day 3, and I'm like, should I sell for $4 or should I keep holding until I get to 6? It actually doesn't matter, because the idea is that whether you sell on day 1 or day 3 or sell here, you will realize all of the profits from that later day no matter what. So whether I sell at, all I have to do is keep track of how much I've increased from my current, or from the value that I bought at until my current value. So I know, and I have to sell when I reach a value that's lower. So if I go to this first one here, and I'm holding it here, and I get to this one, I already know that my profits that I will realize are $4, no matter what. So then if I get, let's say I didn't sell here, it's $4 here, and then I go to the next one, well, then I didn't gain any money, and then I go to the next one, and then my profits are $5. So it's always optimal for me to sell immediately, in the theoretical sense of, like, when we're keeping track of the value, because I know that I will always realize the gains as I continue through the list. So what do I mean by this? So if I start here and then I sell here and then I have $4, then I know I'm not holding anything anymore, so then I'd buy here, and then I'd keep track of an extra $3 because that's how much I've gained, and then I don't sell yet. My current value is still equal to 3, And then I'd go to this next one. That value is less, so now my current value is equal to 4. And now that array is over. Okay, how do we implement this? So we need to basically iterate over our array, and every time that we find a value that is greater than our previous value, we need to add the difference, because we know that if we find a discrepancy that is greater, we will always be able to realize those gains in the end. So we say answer equals 0 and current equals prices at 0. And then we say for I in range. If any of you are wondering about base cases where edge cases in which prices is equal to 0, it says down here that the length will always be greater or equal to 1. So now we say for I in range 1 through length prices, what do we say? We say if current is less than prices I, then we say answer can add the prices minus current, and prices should be at position I. And then we know we should always keep our current, we have to increment our current, right? So we say current is equal to prices at position I. And then we can just go ahead and return our answer. Runs, and it's pretty efficient. Time complexity is O of n, because we just iterate through the list one time.